Hi everyone, in this video I will show how to install ISIS Watcher with BGP-LS support and demonstrate how it works in practice. For installation, we use the simplest and recommended method, the install.sh script, which is available in the README file. After running the script in the terminal, it immediately guides us through the installation process and asks which components we want to install. In this case, we select ISIS Watcher. Next, we choose to connect to a real network device and select BGP-LS as a method for topology collection. The script then asks for required configuration parameters. We provide the IP addresses, configure IS numbers, the ISIS area that we want to monitor and visualize, and select that data should be sent to Topolograph. We also fill additional information such as organization name, watcher name, and agree to start the service immediately. Once installation is complete, we verify that all containers are running and confirm that BGP session is in established state. If we inspect the session details, we can confirm that BGP-LS capability is successfully negotiated and exchanged between both peers. At this point, ISIS Watcher has not received any messages yet, which is expected. Now we enable message transmission. After that, we can observe a large number of BGP update messages in Wireshark. Let's inspect one of these messages. Here we can see a link state advertisement describing the link between R4 and R5. After processing these messages, ISIS Watcher reports that the topology has been successfully published to Topolograph. Now let's take a look at the topology itself. At this stage, we can see a visual representation of our ISIS domain in area 49001. Next, let's change the link metric between R2 and R3. Originally, the metric was set to 23, now we increase it to 2333. After the update, we can immediately see that new metric is reflected in the network topology. The same change is also visible in the corresponding BGP-LS update message where the new metric is advertised. Now let's simulate the ISIS adjacency failure between R2 and R3. We can see that this event is correctly detected and logged by ISIS Watcher. Once we restore connectivity, recovery events are also generated and visualized accordingly. Let's repeat the same test, but this time for a transit link, specifically between R4 and R5. If we inspect BGP update messages, we can observe these events in detail. When we simulate a connectivity failure between R4 and R5, the change is advertised using BGP Withdraw message. When connectivity is restored, a new BGP update message is sent and the topology is updated accordingly. In the end, the topology returns to a healthy state with all links active. If we want to review what happened in the network, which links went down and when, they were restored, we can simply select and inspect the corresponding historical events. That concludes this demonstration. Thank you for watching. Connect your network to ISS Watcher to always know what is happening and what has happened in your network. If you have any questions or feedback, feel free to join our Telegram group.